So my name's Heath. I'm a project manager here with Indigo Power. I'm working on the Upper Murray Reliance and Reliability project throughout the Tawong Shire, predominantly through Corryong, Tintoldra, Tawong, across to Walwa, and back through to some smaller areas, Lucy Vale, etc. And what we're doing there is rolling out around about 27 what we call energy nodes that consist of solar electricity, battery, and backup diesel generators in times of need. Another part of that program is rolling out community scale battery systems, so larger containerized systems, if you like. And the third part to that is heat pumps that are supplied to residences and small businesses that have been affected by fire for either for heavily subsidised rates. So that's where we are. Now, the heat pumps that we work with are supplied by a manufacturing company called Reclaim, and you've got a bit of a visual effect of what they are. So what I'll do is I'll give you an overview of what they do, how it works, and what the main benefits are. And then from there, we can answer any questions that you might have. So the Reclaim Energy heat pump, it works on a very low electricity supply. So in this particular case, as the example shows, around about 850 watts or 0.85 of a kilowatt. The equivalent of the usage that comes out of that is a 1 kilowatt of electrical input, or a coefficient of performance of 5.24, give or take. What that effectively does is creates a very energy efficient way to use electricity against a standard electric hot water system. So imagine that a standard electric hot water system is a little bit like a kettle. Generally speaking, they run off off-peak electricity supply, and from there they switch on at about 11 p.m. at night. That's all throughout the regions, etc., that are on electric off-peak timers, and switch on at a very high rate for around about 4 or 5 hours overnight. And you might actually have them sort of timed out through the day at the same time too. So for the equivalent amount of hot water that you're actually heating within the tank, you're roughly utilising around about anywhere up to 5 times less, depending on the conditions, 5 times less power usage. In this example, we're looking at around about 3.5 times, if you like. The unit is made up of a condenser, effectively, that is CO2 charged. The cold water passes through the unit, comes back out through as hot water, rising to the top, similar to a traditional electric hot water unit, and then is dispersed throughout the house at the time you're using it. There's also a smart controller that's involved there, which can be programmed in operation with your solar power system, or still taking advantage, if you don't have a solar power system, taking advantage of the off-peak timing that you might have there as well. Okay, so we're utilising leading technology to draw energy from the ambient atmosphere and transfer it into heat. So that's roughly what I'd mentioned there. The unit itself effectively operates in up to minus 10 degrees and up to 43 degrees throughout. It's pretty important too that it's fitted with an inbuilt freeze protection. So if it is distributed in areas that maybe get to snow temperatures, freezing temperatures, that you've got access to hot water. Now, there's a bit of a disclaimer there. It would be less efficient at those times where there's less heat in the air. Ideally, you want to operate between 0 to 10 degrees, but at minus 10 degrees, it will still operate. And generally speaking, you'll also have an amount of hot water at the top of the tank available for use. Now, on those days that if you're utilizing the unit as well, you do have the controller, which gives it a boost function. So if you're finding that you're short of that hot water throughout the day, you can quickly and easily switch that on. From there, we've got, it's suitable for all Australian conditions and variations in the climate. So it's been specifically designed in Australia. It is very quiet in terms of the level of noise that it produces. So similar to an air conditioning unit, if you've stood by one of those, very much like the fan operating there. of course, environmentally friendly, and therefore it is eligible for additional rebates and government incentives that occur. So the company that manufactures Reclaim is an Australian-owned company. They manufacture the tank in Australia. The controller is their IP effectively that works in unison with that heat pump. And you've got an Australian, the compressor is manufactured in Japan, and like I'd mentioned, specifically for Australian conditions. So the benefit that you've got when you've got the pump controller is you're able to customize your hot water management to optimize your solar energy production. So consider it like operating as a 4 kilowatt hour battery for the house, without maybe the expense, but also having a bit of a multi-use, if you like. So you're sitting there using it for water, which you use readily. You're having showers each day, all that sort of stuff. So it's quite functional in terms of its operation as you need hot water daily. A battery could be too expensive for some people, but this may be a worthwhile investment around that. And I'll get into some of the simple paybacks, if you like. As mentioned, there is a controller. It has 5 presets that are set within that. One of the presets that is most beneficial if you do have solar power is to have that switch on from around about 10 a.m. In the day through to around about 3 p.m. So it's ready to be utilised at the later end of the day, and will also be hot overnight, ready for that morning shower. The benefit there is that if you're utilising your solar power, like it was mentioned, it's essentially like a liquid-fired battery, therefore storing that excess solar energy that would ordinarily be pushed out into the grid for around about 6 or 7 cents per kilowatt hour, and taking advantage of those daytime tariff rates of around about 30 cents, and therefore making some direct savings around that. As mentioned, you can have a single shot boost, so you can guarantee that you're going to have hot water at any time that you need to. Okay, so the average running cost of a heat pump around about $360 per annum. Obviously, it'll be a little bit dependent on your circumstances. So if you've got a house of 10 or 12, I think you might find that might be a little bit higher. If it's maybe a couple of you, it'll be a little bit lower. The estimated payback that we would then see would be around about 3 years. So roughly speaking, if you're utilising a traditional hot water service, it would operate on that off-peak time, and it would cost around about $1,200 per year to run, give or take a couple of dollars there. What we have, the energy saving, you've got the top-down heat pump returning heating for rapid water recovery. So when you hit that boost button, it does recover very quickly, roughly 15 minutes. You'll find that you've got hot water back in if you happen to have used all that tank water that's in place. The average annual energy saving up to 80%. Utilizing CO2 refrigerant, which is naturally environmentally friendly, designed specifically for the system, and built-in frost and freeze protection, so that if some of those pipes, etc., ordinarily on some other systems in freezing temperatures would freeze, this offers some protection around that, obviously up to negative 10 degrees. Long warranties, very much important around putting these items in for anything. There's dollar payback, but there's also environmental payback from actually producing these units. So the Reclaim glass line tank is warranted for 10 years. We've got the heat pump main, 6 years, and we've got the controller and sensor for around about 2 years there. So fairly expensive, really looking to get the full usage out of those units as best as possible.